section 1.3, which is about problem solving. Almost any math book that talks about problem solving starts out talking about the writings of a Hungarian mathematician named George Polya. He was brought up in Hungary, but ended up coming to the United States, I think, in maybe the 1940s, and then taught mathematics at Stanford University, and wrote a very famous book called, I think it's called Problem Solving. I'm not sure about that. I've ordered the book and I've never actually read it, but below you're going to see what are commonly written as his 4 steps in problem solving. Number 1, understand the problem, and you may have to read it more than once. Number 2, devise a plan. Now, this part is very, very open and differs greatly for different kinds of problems. Sometimes you'll use inductive reasoning, sometimes you'll make a list or a table, you might estimate and come up with an educated guess. Sometimes you will create a similar but simpler problem. You might use trial and error, chart or table, sometimes sketch it. Sometimes you begin to catalog problems and say, oh, this is a time, rate, distance problem. I solve it this way. Oh, this is a liquid mixture problem. I solve it this way. And then finally carry out the problem and solve it. And then it is such a good idea to look back, make sure that the answer you get satisfies the conditions, as well as makes sense and is reasonable. Sometimes you just will recheck your method or your calculations. Now, I don't recommend, and most people don't recommend, that you memorize these steps, but I just want you to be aware of this, and if you're successful, you are probably using it even if you didn't realize it. All right, let's see if we can solve a couple of problems. Make this a little larger. It says, number 1, if a student saves $22 per week, how long will it take to save enough money to buy a computer? What necessary piece of information is missing that prevents solving the problem? Okay, you know how much they make per week, wants to know how many weeks to save enough money to buy a computer, but what do you not know? You don't know the computer's price. So there's no way to tell how long. If the computer costs $44, it's only going to take 2 weeks. But you would have to know the computer's price. All right. So we're just looking at information and seeing if we have enough. We're not solving anything right now. If it takes you 3 minutes to read a page in a book, how many words can you read in 1 minute? What is the necessary piece of information that is missing? All right. Well, it takes you 3 minutes to read a page, but that's not talking about how many words. So, the number of words on a page, you'd have to know that so that you could find out how many words you could read in 1 minute. So, we'd have to know the number of words on a page. So here it's 3 minutes per page, but then they switch over and say, how many words can you read? Well, I don't know, because I don't know how many words are on a page. All right, let's move on. A parking garage charges $2.50 for the first hour and $1 for each additional hour. If a customer gave the parking attendant $20 for parking from 10 a.m. to 3 p.m., how much did the garage charge? What piece of information is missing. I'm sorry, I just made a critical mistake that students make. Which piece of information is not necessary to solve the problem? Not which piece is missing this time. Which one is not necessary? Well, look over it. $1, that was necessary if you're going to calculate. $2.50 for the first. That's necessary if you're going to calculate. $20 the customer gave the parking attendant. Does that affect what the garage is going to charge? No, they didn't ask you about how much change. They didn't ask if you gave them enough money. You don't need to tell them about the $20 that the customer gave the parking attendant. So that is the piece of information that is not necessary. So please don't make the same mistake I just did and think that if the first two questions talking about missing information, that so is number 3, read them carefully. Okay. There's another kind of problem that we're going to look at. It's a generalization of our work in example 2, and I'm sorry you're not seeing example 2, allows you to compare different brands and make a choice among various products of different sizes. When shopping at the supermarket, a useful number to keep in mind is the product's unit price. The unit price is the total price divided by the total units. One thing I always remember is money on top. That's kind of silly, but I always remember money on top. Among comparable brands, the best value is the product with the lowest unit price, assuming that the units are kept uniform. All right, the word per is used to state unit prices. For example, a 12-ounce box of cereal sells for $3. Its unit price is determined by total price, $3, total units, 12 ounces, do the division, and it is 25 cents per ounce. Now, I actually would prefer that it said 25 cents per ounce and write it like that, but they want to use the word per instead of the fraction line. Okay, so we're going to do that, and we are going to, even if we're not thinking about it, we are going to use Polya's 4-step method. All right, we have a 15.3 ounce box of cereal and a cost, and a 24 ounce box of cereal and a cost. Now the 24 ounces costs more than the 15.3 ounces, but that makes sense. But which one is the better value? Well, we have to compare. Remember, money on top. So for the first one, we will put $3.92 for 15.3 ounces. We will compare it to the $4.55 box that contains 24 ounces. All right, if I do this division, and I'm going to do it off camera, use my calculator, and it is approximately 26 cents per ounce. The other one is approximately 19 cents per ounce. So which is the better value? The better value is the one with the lower unit cost. So the 24 ounce box is a better value. Now, if you don't have but $4.25, you can't get the 24 ounce box. But if you can, you are getting a better deal for the volume of cereal. All right, now let's take that and go a little bit further with it. It says, a supermarket displays a unit price for the 15.3 ounce in terms of cost per ounce, but it displays the unit price for the 24-ounce box, in terms of cost per pound, what are the unit prices to the nearest cent given by the supermarket? All right. Now, if we're asked to find, for the first one, cost per ounce, we've already done it, and it's 26 cents. Now, if I'm doing cost per pound, then I would have to change the 24 ounces to find out how many pounds there were. Okay, well, if you have 24 ounces, and we'll do more of this later, and you know that 1 pound is 16 ounces. The ounces cancel. I divide 16 into 24 and I get 1.5 pounds. So this 24-ounce box is really a 1.5 pound box according to the way the grocery store has decided to do this. Now, its units cost now is money on top. It is still $4.55, but now I want the unit price per pound, and it's 1.5 pounds. So remember, this, I just had to do this conversion to change ounces into pounds, and I might have to look up that there were 16 ounces in a pound. Now I do this unit price and get that it is $3.04 per pound. 3.04. Now, nothing changed in the amount that you're buying. It's still 15.3 ounces and it's still 24 ounces, but now they're calling it 1.5 pounds. It's the same amount of cereal. But based on your work in A and B, does the better value always have a lower displayed unit price? And the answer is no, if the units are different. Now, they didn't ask you to justify that, but I just did it for us. Okay, so make a note of unit price, and in up here, here's your formula: total price divided by total units. And if you're going to compare them, for a good comparison, they need to be in the same kind of units. All right, number 5. Shrink that down a little. And it says one person earns $69,000 per year. Another person earns $3,500 per month. How much more does the first person earn in a year than the second? Well, $69,000 per year. The other one is per month. So if I have, I just touched things and made them go everywhere. There we go. All right. So I'm going to compare 69,000 to 3,500. That's per month, but I want it expressed in years also. So I'm going to multiply 3,500 times 12, and that's going to be 42,000. Just off screen, I've done that calculation. So first person, 69,000 per year. Second person, 3,500 per month. So per year, I'd have to multiply by 12. So I get 42,000. How much more does the first person earn than the second? So I need 69,000 minus 42,000 to get that difference, and it is $27,000 more. Big difference. But you can't compare them when the units are different. So you have to convert. You could have divided this one by 12 to get their their salary per month. But I would rather multiply than divide if I have a choice. All right, let's look at number 6. A television sells for $800. Instead of paying the total amount at the time of purchase, the same television can be bought by paying $100 down and $100 a month for 14 months. How much is saved by paying the total amount at the time of purchase? So I'm going to be comparing the $800 if you pay it at the start versus if you pay it out. Well, if you pay it out, you're going to pay $100 plus you're going to pay $100 per month for 14 months. Okay, so that is 100 plus 1,400, which is $1,500. So you're going to compare $1,500, which is what you pay back in a form of credit, to the $800 if you paid cash. So the difference, if you subtract those, is $700. It is almost, you could almost buy 2 TVs. All right. Let's look at number 7. All right, we are going to buy and sell calculators. Calculators were purchased for $90 per dozen and sold. All right, we've got these calculators, $90 per dozen, sold them $25 for 3 calculators. And so once again, $90 per dozen and $25 for 3 calculators, and that was the selling price. So it wants to know the profit on 6 dozen calculators. So I would say that we have to figure out the cost of 6 dozen calculators and the revenue, or the money brought in, for 6 dozen calculators, so that we can find out what the profit is. The profit is the revenue, money in, minus cost, which is money out. All right, so let's look at, well, let's start with the way it's written. All right, the cost. It's $90 for a dozen, and we're going to sell 6 dozen. So the cost of 6 dozen is $540. All right, that's my cost. Now, my revenue. I know that word is not used in the problem, but revenue is money that comes in from the sale. Okay. Now in this one, I keep trying to add a dot to that. It's $25 for 3 calculators. Well, that's not a dozen. Okay, a dozen would be 4 sets of those 3. So I could say times 4, which is $100 per dozen. But we're going to sell 6 dozen. So I'm going to take $100 times 6. So we have a revenue of $60. So my revenue, $600, my cost of $540, both of those are for 6 dozen. So we have $60 is our profit. Now you didn't have to do it in this order, but you had to recognize that your profit is your revenue minus your cost, even if you don't use those words. It's money coming in subtract money going out. But it had to be for 6 dozen. The cost was easy because it was priced per dozen. Multiply it by 6. But the money coming in was $25 for 3 calculators. But I want to know what it is for 12 calculators. So I multiplied by 4. $100 per dozen, 6 dozen, $600, and then I subtracted. That one was pretty challenging. All right, let's look at number 8. It says each day a small business owner sells 200 pizza slices at $1.50 a slice and 85 sandwiches at $3 each. Business expenses come to $80 per day. What is the owner's profit for a 10-day period of time? Okay, same thing. I've got to get cost and I've got to get revenue. This time, revenue is mentioned first, and the revenue is $200. I'm sorry, it's 200 pieces of pizza. 200 times $1.50 plus 85 times $3. This is each day. So each day they earn, and we can calculate that, $555. Oops. That's in one day. So in 10 days, if we take $555 times 10 days, will give us $5,550. Now, the cost is $80 per day, but we need to know the cost for 10 days. So the cost is only $800. So let me shrink. I have my revenue. I have my cost, both of those for 10-day periods of time. So then subtract. If you take $55,550 and you subtract $800, you get a profit of $4,750 for the 10 days. Okay, so this is another problem where we're looking for profit, and remember that profit is revenue minus cost. It doesn't matter which one you calculate, but it does matter about the order you subtract. It must be profit is revenue minus cost. Perhaps write that down. Okay, number 9. It says a car rents for $280 per week plus $1 per mile. Find the rental cost for a 2-week trip of 500 miles for a group of 3 people. Okay. It is $280 per week, and we're going 2 weeks. So it's $280 times 2 plus $1 per mile, and we're going 500 miles, so I don't really have to multiply that out. It's $1 times 500, and if I add that all up, I use a calculator off screen to do that, I have $1,060. Now, when you read the question, you might think that you're going to do something with the 3 people. It does not ask about what is the cost per person. It just wants to know their rental cost. And so that's all there is to that problem. But a lot of people will think they need to do something with the 3. It was extra information that we didn't need. And good problem solving does include recognizing when you don't need some information. All right, last one. It says Brianna decided to ride her bike from her home to visit her friend Adam. 2 miles away from home, her bike got a flat tire and she had to walk the remaining 3 miles to Adam's house. She could not repair the tire and had to walk all the way home. How many more miles did Brianna walk than she rode? Okay, this is one where I think a little diagram would help. Okay, she starts at home. She goes 2 miles on her bike. She gets a flat. She walks 3 miles. And then she's at Adam's. Then, because she can't get the bike fixed, she has to walk all the way home. Well, it's the same distance coming and going, so it's 5 miles, and it's this entire part is walking. This is home. So the question again is, how many more miles did she walk than she rode? Well, the walk was 3 miles plus 5 miles for a total of 8 miles. The bike was only 2 miles. So how much more did she walk than she rode? It's going to be 8 miles minus 2 miles, or 6 miles more walking than she rode. Now, what I hope you may have gotten out of all this variety of questions is that even though we did many of them different ways, we looked for similarities if they existed. We drew a picture when that would be helpful. We recognized some formulas that would help us a little bit. We talked about unit price and certainly recognized that the units need to be the same to have a good comparison. And then we did talk about missing information and extra information. So I hope that you will be a slightly better problem solver after this lesson.